Hello friends. So in this learning series of statistics, we will try to discuss statistics. So as I previously told you about statistics in general, basically we try to we have certain collection of data and we try to interpret those data or try to analyze those data. So the data needs to be calculated whenever we have certain data. For example, if you are like planning for your monthly budget, or if you are planning for writing your family's name, so you will have some data. It will be a data, and you will represent those data in an order. So statistics is basically a collection of data and tabulation and interpretation of numerical and vital or general data. It is an area of applied mathematics concerned with data collection, analysis, interpretation and presentation. So analysis, interpretation and presentation, these are the data collection area where we try to apply some mathematics or some concerns on that particular data. So what I try to say, if you have your family's members data, so we will write in some order, like your father name, your mother name, your grandfather, your grandmother, and your nephews and your sisters and brothers, siblings. It have some sequence or hierarchy. So this hierarchy will be an order, or this is a tabulation, or this is an interpretation, or this is a I can say a representation of your data. So this is a statistics where lies where we have to see how data can be used to solve complex problems, or what the output can be returned from your data. So understanding the descriptive statistics over here. So in the layman term, if we say, so descriptive statistics generally means describing the data with the help of some representative methods like charts, tables, Excel files and etc. So these Excel files or the tables we are talking about, the thing is there, if you try to explain try to write your family's member name, or date of birth or age, or something around your information about your family, or something about your like a company or employees or people, or your like how many people are into your street. So if you are calculating those data, so it must be represented in an order, or must be implemented in chart, tables or Excel files. So these things must be implemented in a sequence. So this sequence is required to input your data. So this is the way we try to explain the descriptive statistics. This is us descriptive statistics, where we describe our data in an order, okay, or in a form of charts and tables. So this by which we can say the data is described in such a way that it can express some meaningful information that can be also be used to find some future trends. Describing and summarizing a single variable is called univariate analysis, or describing relation between two variables, which is bivariate. If we like say multiple variable is describing the relationship between multiple variables means multiple entities or multiple people, we try to combine multiple data, so it will be a multivariate analysis. So this is an analysis type, what we are trying to analyze from this. So if I'm analyzing this halfer line and these halfer line, you try to understand this. Let me explain this in this presentation over here. So this is how we can analyze the data. So analyzing the data, you should have some certain criteria to analyze the data. But in those criteria, you have like a combination of data. So those combination will be create some logical information, summarization you will have to do. So if two variables needs to be calculated, so this will be called bivariate. Okay, if a single variable, you are analyzing a single variable only, single data only, this will be univariate. And you are describing the multivariate. This is where we try to implement some multiple values. So if we try to if we try to like if we try to measure the descriptive statistics, so measure the measure of central tendency, measure of variability, these are two descriptive statistics type. Here we can say types of statistics, descriptive statistics and inferential statistics. These are the two types of statistics we have. Okay, so so this measures of central tendency, which I already told you in the previous sections also, previous videos also, that every statistic should be measured, or the measurement should be in an order which will be lies in categories like mean, median and mode. Okay, so this will be the measure of central tendency, where mean is the sum of observation divided by the total number of observation. Means number n is provided, so the sum of n numbers and number, how many data are there, 6 or 7 or 10, or the sum of all the data and the number of data will be divided by the number of data. So this is how we can summarize mean. Okay, the mean function in if we try to implement on logic on program, so mean function returns some value, so you have to create some mean function, so it will provide average of the data passed in its argument. Okay, so we have certain this is we are using into Python, we are importing some statistics. Okay, so now we have lists, so this list will be trying to summarize average of this list. So we'll provide a mean function. So mean function will print this list, and the output will be 2 over here. Okay, and if we try to find such data through median, so this is median, where we create two halves of the data, and the two halves will be if the odd number is there, the center element will be the median, and even the median would be the average of two central element. If there is two central element, there is no odd number, there are even numbers, so two central element over there, so then the output will be average of the two central element. Okay, so this is how median function is used to calculate the median, and with middle element of the data is passed and the argument and empty statistic error is raised. Okay, so this is how very important from the median. So now this is a data 1, this is a data 2, like this is a positive integer number, this is tuple of floating point number, and tuple of fractional numbers, tuple of set of negative integers, set of positive and negative integers. So these are the numbers we are having. So how we are calculating median? So median for data 1 is this we represent into this when we try to output the value of this integer, so it will be into s, this percentage s, and this is percentage s. Yes, so this is okay, and this is how we create median. And then there is median low. Median low is there, so median low function will return the median of the data in case of odd number of elements. So but in case of even number of elements, returns the lower of two middle elements if the passed argument is empty, so statistics error is raised. Okay, so median low is like importing a statistics over here. Now set of data is provided over here. Now print will work the statistic median set 1, and this set 1 also is printed in the low here. So what will be the output over here? 3.5 and 3 for this series set 1. Okay, and median high is also there. The median high function returns the median of data in case of the odd number of elements, where odd number of element there. So half of the series will be gone, half of the series will be gone, central number will be provided to you. So this will be like if the series into the order, so this half a number will be gone, this half a number will be gone, and the output will be 3.5 or 4, just like you can see over here, this number will be. Okay, so median of this set is 3.5, high median of this set is 4, the average of this. Okay, you can print over here from statistic.median. So this is the library which you use to import statistics calculation. Mode is also available. Now we discussed about mean, median. Now mode is, it is the value that has the highest frequency in the given data set. If we are having certain data, we have a highest frequency, so the mode will be there. The mode, we will find the mode when there is highest frequency. So the data set have may not no mode if the frequency of all data points is same. So also we can have more than one mode if we encounter 2 or more data points having the same frequency. Mode function returns the number with the maximum number of occurrences. So the mode function returns the number with the maximum number of occurrences. If the past argument is empty, statistic error is raised. Okay. So mode function will return the number of maximum number of occurrences. How many number of occurrences over there for the particular data. Like data one tuple is integer number is provided here, floating point number is here, fractional numbers are here. So data 3 in this negative integers are there. So the now string is also available over here. Now meta mode 1 mode we are trying to calculate through the statistic classes. So importing mode from the statistic classes. Now we try to implement the 5 will be provided to this mode. Highest occurrences is 5. Here is highest occurrences 1.3 I guess, and this is the highest occurrences is 1 2 or 2 3. This is 1 2 over provided here, minus 2 is here, and black is provided over here. So the output, all these are this. Okay. So how we try to grab the data, like we the occurrences will count the occurrences for the mode, and it will be in Python you can easily find the mode by importing libraries for statistics and median mode and mean also. So now we have like measures of variability. There is there is diagram we showed that how we can work through statistics. So this statistics will having descriptive statistics, measure of standard tendency, measure of variances. Okay. So this is measure of standard tendency where we already discussed. Now measure of variances we will discuss. Then we will discuss inferential statistics. So let me go to this topic. Yeah, this is measure of variability. Now this is the range, variance and standard deviation. So this is the two techniques where we try to we already discussed the measurement of central tendency. Now we are definitely measure of variability. Central tendencies also will. So this you must know how descriptive statistics and variance statistics will do. There are two statistics only, but here in description there you can find 6 types, like one in measure of central tendency, and this is one in measure of variability. So measure of central tendency you will find mean, median, mode, and measure of variability you will find range, variance and standard deviation. So range, the difference between the largest and smallest data point in our data set is known as the range. The range is directly proportional to the spread of data. That means the bigger the range and the more the spread data, and vice versa. So the range will be larger data value and the smaller data will be range will find. So this is how this max and min function is working over here. So array is provided, max function will provide the maximum range and largest values, and this is minimum values. Now we will divide minus this, so we will find a range. So this is how this simple format is created in the Python. Then we discussed range, now variance, and then standard deviation. So range, variance is defined as an average squared deviation from mean. Okay, this is average squared. It being calculated by finding the difference between every data point and the average, which is also known as the mean. Squaring them, adding all of them, then dividing by the number of data points present. So it looked like we did in our 11th standard or in our 12th standard for working for economics, so statistics. So these things are already available in our secondary classes also, and if we try to implement the programming logics, so these topics will be interesting, and this topic will be useful whenever we try to manipulate some data or Whitest-Stats data or any of the data, right? So where n number of terms, u means mean, And the variance we find statistics module provides the variance methods that does all the maths behind the scene. It passed argument is empty, statistical error is raised. So this is how importing variance. Now we are importing variance from statistics, and from fractions we importing fractions as FR. Okay, this is the FR will the name. So now we'll calculate from the FR. Okay, the sample data is available over. Positive integers there, negative integers there, spread apart. These are negative, positive. These are fractionals. Okay, and these are floating point numbers. So now we'll be try to variance from this. So what will be the output over here? Statistics module provides a variance method that does all the maths behind the scene. So these maths are behind the scene, but number of terms and mean. So mean, what will be the average square deviation of the from the mean? It is being calculated by finding the difference between every data point and the average, which is also known as the mean. Okay. So average it will be if you find variance, so you have to calculate the mean also, then the difference between every data point, so it will be variance. Okay, so this is how variance will be calculated. You can calculate this, or this is already provided in the in the libraries of the Python. So first you must understand this topic, understand the topic, and then Python have certain libraries which you do not have to require calculation behind the scene. The Python will create all the calculation behind the scene without your much effort. But first, what you have to know, what is going behind this the scene, what is going actually when we try to implement the logic. Okay, so you have to know all the requirements. Okay, so standard deviation, now for standard deviation, if we like want to work on standard deviation. So this is the deviation in the chart. We can see standard deviation over here, range, variance, and standard deviation. Now we'll discuss, and then the last but not the least, the topic we discuss inferential statistics. Okay, so this is how it will be go. Standard deviation now. Standard deviation variance is available over here, and standard deviation, it is defined as the square root of the variance. Now variance from the mean and the minus of all the values ranges, then like squaring these values from the variance, it will be provide you standard deviation. Okay, so it will be calculated by finding the mean, then subtract each number from the mean, and then also known as the average of then the result will be squared. So these will find the standard deviation. So this library is also provided in stddev method. So you can find stddev and import the stddev, standard deviation dev, and fraction and FR. Now we can use those stddev method of the sample data or this provided. So this will be given this standard deviation. This is how we try to implement these things. Okay, so this is the main actual statistics provided over here, where we try to we discuss the types of statistics, where descriptive statistics of measure of central tendency, where mean, median, mode is calculated, and here is variance and standard deviation and range is calculated. So this is 6 topics over here, 3 topics over here, 3 topics over here, and this is the how descriptive statistics will be calculated. Pie charts, graph, and bar graphs, whatever it should be in order. So we'll in the next video we'll discuss an inferential statistics and or more into the statistics. Till then, thank you, bye, and good luck.